I welcome you to my new video. So today's topic is lower bound, upper bound, and search insert position, lower in the sorted and Ceil in the sorted. So we'll submit it all. So first let's take lower bound and try to understand what it's saying. Given a sorted array and a number target, the task is to find the lower bound of the target in this given array. The lower bound of a number is defined as the smallest index in the sorted array where the element is greater than or equal to the given number. If all the elements in the given array are smaller than the target, then the lower bound will be the length of the array. Okay, so what it is saying, we'll understand it with the example that 2, 3, 7, 10, 11, 11, 25. Target is 9. So we have to find an element which is greater than or equal to the given number. Which element is greater than or equal to 9? I am seeing 10, 11, 11, 25, but we have to return the smallest index. So which is the smallest index of 10, which is 3. So here is the lower bound. What is the lower bound of 11 in the same array? We have said greater than or equal to. 11 is greater than or equal to, and 10 is less than. So we will take 11, and we will take the first 11 because we have to find the smallest index. So its index is 4. So our output is 4. Now what is our target? Our target becomes 100. Now we will search in the array. Do we found any element which is greater than or equal to 100? No. So what is our output? We have said in the question statement that if all the elements in the given array are smaller than the target, the lower bound will be the length of the array. So the length of the array is 7. So answer will be 7. Let's do the dry run on this question. I will take an example. So this was our question example dry run. We will do. Let's take a low pointer. We will do a binary search. Because we have to search an element. So why will search in big of n time? When we do it with binary search, we can reduce the left part and the right part. We can trim the searching space and we can reduce our time. Why would we use the linear search of big of n? Now, what is the mid? Index is 0, 1, 2, 3, 4, 5, 6. 0 plus 6 is 6 by 2 is 3. Mid is here. Is 10 greater than or equal to 11? No. And initially what we have to store in answer? Length of array, which is 7. Okay. So 10 is not greater than. So what we have to do? Now this means we cannot find our answer on the left. So we will trim the left search space by increasing our low to mid plus 1. Now what is the new mid? 4 plus 6 by 2 is 5. New mid is here. Now 11 is greater than or equal to 11. Yes, we will update our answer to this index, which is 5. But we are not sure it is smallest. We have to return the smallest index. So we cannot get on the right because 11 is greater than or equal to. So if we will move right, then it is not the smallest index. So we have to search on the left. So we will do high to mid minus 1. Okay, mid minus 1. Now 4 plus 4 by 2 is 4 only. So mid is here. Mid is here. Now check 11 is greater than or equal to 11. Yes. So answer becomes 4. What we have to return? Now we have to return the answer 4. But before this, now this was also check one more condition because we are not sure still that 11 is the smallest index. So we will update the high to low minus mid minus 1, which is here. Now when high moves here, it becomes less than low, which breaks our while loop because low should always be less than or equal to high. It's break this condition because it becomes false. So we will return answer to be 4. Let's code the solution and it would be submitted. Let's code this int equals to 0 and high equals to array dot size minus 1. Last index would be array of size minus 1, and our answer would be initially array dot size. If it is not found in the array, so it will be, for this example, I'm thinking while condition was low, should be less than or equal to high. What is the mid? We have seen in our last video, we can write mid like this: high minus low by 2. And now we have to check if array of mid is greater than or equal to target. If yes, then what we can do? We'll store our answer. If and Now we are not sure it is the smallest index, so we will move our high pointer to mid minus 1. Else what we can do? Else what can we do? Else we can just trim the left search space to mid plus 1 by doing it mid plus 1. Return the answer. Run, submit, and boom, it got submitted. Now let's move to next question, which is upper bound. What is this thing? Given a sorted array and a number target, the task is to find the upper bound of the target. Upper bound of a number is defined as the smallest index in the sorted array where the element is greater than the number. Previously it was greater than or equal to. Now it is greater than. So very less change. If all the elements in the array are smaller than or equal to the target, the upper bound will be the length of the array. Simple. We'll take this example only, and this time it will be of upper bound. So I think this example would be good enough. This example only. Let's take this example. Yeah. Let's rub this. Okay. Let's rub this. Initially our answer is this, and mid is okay. Now low is here, high is here. Where is mid? Mid is here. Now we have to check greater than, just greater than. We can see the word test case also. What is greater than 9? 10. What is the index of 10? 3. Which element is greater than 11? 25 only. So it will return the index. No element is greater than 100. So we will return the length of the array, which is 7. Okay. Let's do this random. Greater than target, we have to find out. Smallest index, which is greater than target. Smallest index, which is greater than target. Okay, let's move. 10 is greater than 11. No. What we have to do? We cannot find the left. This means we have to update the low pointer to mid plus 1. Now where is the mid? Here. Is 11 greater than actually not equal to greater than 11? No. So we can again move the left pointer to here, and now see what is the mid? Mid is 6. Is 25 greater than 11? Yes, but we are not sure it is the smallest index. So what we can do? We can update the high pointer to here, and also we can update the answer to 6 first. Now we will update the high pointer to mid minus 1, because mid was here. Mid minus 1, which is here. Now high become less than low, so while loop breaks, answer is 6. Let's code this. Let's copy this question, lower bound solution only, and we have to change a small bit, little bit, just to remove this equal to. Yes, now it will be submitted. See, it is going to submit it. Yeah, all text is passed. Now see next question. Given a sorted array of distinct integer and a target value, return the index if the target is not found. If target is found, return that index. If not, return the index where it would be if it were inserted in order. You must write an algorithm with big of log n runtime complexity. What this question is saying is, suppose 5 is there in the array, return the index of 5, which is 2. Suppose 2 is not there in an array, but where could be 2 possible in a sorted array? Between 1 and 3. If it was inserted, what is the index of 2 now? It would be 1, simply. So, but how to find this? We can use the lower bound concept. How? See, 3 is greater than or equal to 2. See, the 3 is the smallest index, which is greater than or equal to 2, and its index is 1. If we will found an element which is greater than or equal to the target, we can return that index, and that would be our answer. And suppose it is target is 7, 1 2 3 4, 7 would be inserted at last, so we can just return the last length of the array, which is 4. So we can just copy our lower bound code, and submit it like this. See, no change, and I will submit it. compilation error. Actually it is not array, it is not nums, it is array. Okay, yes. Now move to our next question, which is floor. What is floor? It is not a floor and seal of our room, but it is similar like this. Floor is down. So what is given a sorted array, an integer x. Find the index 0 based of the largest element in the array that is less than or equal to x. This element is called the floor of x. Largest element that is less than or equal to our target, which is x, this is called the floor. If such element does not exist, return -1. In case of multiple occurrence of floor of x, it is not Ceil, it is floor of x, return the index of last occurrence. So we have to give the last occurrence of our floor, which is the largest element, which is less than or equal to our x. Okay, because it is a sorted array. Let's take an example, then you will understand more. 1, 2, 8, 10, 10, 12, 19, and x is 5. What is the floor of 5? Which is less than or equal to 5. I can see 2 is less than 5, 8 is greater than 5. So I can say 2 is our floor, which is 1 index. Now, floor of 11 is, I think 10. And its index is 0, 1, 2, 3, 4. So answer is 4. Now see, floor of 0. I cannot see floor of 0. So we will return -1. So it is also simple question. I will do the dry run for you. Let's do the dry run of this floor question. Let's take this example. Yes. Now see. We have to find the floor which is less than or equal to. We have to find the last occurrence. Okay. Now see the mid is 3. Is 10 less than or equal to 11? Yes, but we are not sure. It is the last occurrence. So we will move our left pointer to here, low pointer to here. Now see, what is the new mid? New mid is this. Is 12 less than or equal to 11? No. Now we will update the high pointer. Initially, what was the answer? -1. What would it was updated through? It was updated to 3. Now again, mid is on 5. It is not updated. We move the high pointer to mid -1. High pointer is here, and now new mid is also here. Is 10 less than or equal to 11? Yes. We will update the answer with 4. Now again, we are not sure it is the last occurrence, so we will update the low pointer to right, mid +1. And when low becomes greater than high, our value breaks and condition fails and answer returns to 4. And see, our answer is 4 only. In this condition, we will write a code simply. We can just use this template, copy, just paste this, update it to target, and just to initialize it with -1. Now less than or equal to target. If it is less than or equal to target, we will update what? We will store its index, and we have to find the last occurrence. Now our low pointer will be mid +1, and else if it is greater than, if it is greater, we have to search in the left. We have to trim the right part now. Mid -1. Submit. And boom, it got submitted. Similarly, Ceil. See the Ceil question. Given a sorted array, an integer x, find the index 0 based of the smallest element in the array that is greater than or equal to x. This element is called Ceil of x. If such element does not exist, return -1. If Ceil does not exist, return -1. And we have to find the smallest element that is greater than or equal to x. Greater than or equal to x, and the smallest index, it is similar to lower bound, exactly similar to lower bound. So I can just paste the lower bound code, I think. Smallest index greater than or equal to, see, smallest index which is greater than or equal to the given number. Only one condition is changed here. Initially it is, if it is not found, we will return -1, and here it is target. Let's submit this. Yeah, it is submitted. Okay, so there is one more concept of that there are lower bound and upper bound function in C++. direct function. So if you have to calculate the lower bound, you have to write lower bound. If it is vector, you would write array dot begin, array dot end, comma, what you have to search, and it will give you an iterator. So you have to, for index, you have to subtract it with array dot begin. Suppose array dot begin is here and lower bound is here, so we will subtract it and get our index. So this condition will help you. If it is array, you can do array comma array plus n, because it is a base address, and this is the size length of the array. Okay, and if for uppercase, you would just write this upper bound. Yeah, you will get upper bound. So this was the small concept. Hope you liked the video. We'll meet in the next video. Till then, goodbye.